Okay, so for the first secant and tangent line worksheet, we were given the equation st equals -16t squared plus 128t, and that is what this graph is showing right here. I used Desmos. We found that our maximum point is 4, x equals 4, y equals 258, and then Desmos also gave us that it crosses the x-axis at 0 and at 8. We are then given instructions to find our secant line, which is a line that goes through 2 points in a graph. So when we find we have t equals 1, then you can go to x at 1 and go up to your graph and find that point. And then you have t equals 4, go to 4, find that point, and connect them. So this is our secant line right here. Finding the slope of the secant line, you just take the values you're given. So you have your xy, another xy, and you plug that into your slope equation, getting s equals positive 48 feet per second. The next question is asking us, what do we know? Well, by having a positive slope, you know that it is going upwards. With the positive slope, we do not know the actual speed. We only know that it's going upwards. The rock is being projected upwards. The speed the secant line is an average, so that only tells us the direction. If we had a tangent line, that would give us a specific speed that the rock is going at on our graph. But since this is a secant line, we only know the direction. When we flip the page, we then get our table right here of different intervals, slowly getting smaller and smaller. And with these intervals, you know that it's a secant line because that's 2 points that it's crossing our parabola. And what you can know is that by these intervals getting smaller and smaller and smaller, you're getting closer and closer to it being just 1 point on the line. So that's why by having them start far away and get closer and closer, we can estimate and approximate that our slope of our tangent line is actually going to equal 88 when t equals 1. This question here, we are trying to find the other tangent line, so the one on the opposite side, which would end up being a negative slope. And the way we do that is we get our original equation, set it equals 0. Using the AC method, we can factor out the x's and be able to see that we get t equals 7 and t equals 1. So we already know that at t equals 1, our y point is 112. So we can use the 112, flipping our parabola on the vertex. We can use the same positive 112 and 7. So x equals 7, y equals 112. And then you know by graphing the line, which is right here, you see that it is a negative slope, and that is showing that the rock is going down. We then are asked to find a point on the graph where the instantaneous velocity is 0. And we know that the only place where it could hit the parabola at only one spot is at the maximum point on the parabola, which would be right here, again, for x equals 4, y equals 258. So we know that that's the only point where it would hit it once. And so we get a horizontal line, which we automatically know the slope of a horizontal line is 0, meaning that the direction speed is 0.